4.4 proportions and scales. I can solve using scale factors and scale drawings.
We didn't do much with scale drawings, although I did a couple of crude drawings, but can you solve proportion using scale factors, Bella? You can now use scale factors to solve proportions. How many of you agree? You can use scale factors to solve proportions. Raise your hand if you say, yes, I can do that.
Yes. Yes.
Sweet.
Yes.
Cool, cool, cool. So, excuse me. A scale factor, very important vocab word. Scale factor is a ratio. A ratio is another name for a ratio. Everybody.
A fraction.
Another name for a ratio is a fraction. So a scale factor is a fraction that shows the relationship between the actual and the representation. So when I built my house, my builder came over with sheets of paper and he showed me what my house would look like. Was that the representation or was that the actual?
Representation.
Obviously it was the representation. However, did the representation proportionately align with the actual? So in other words, on the drawing, was it proportionally exact to my actual house?
Yeah.
Yeah, so when we flip down here to, I think I drew a house for you guys right now, or earlier in the notes. When we go down to my house here it is. See the house? So when my builder came over to where I was living before I built my house, he said, here's what your house would look like. And I said, really? And he said, yeah, the scale factor is 1 inch to 5 feet. So I said, so my house, because I measured, was 5 feet across on the paper. I knew that 5 plus 5 plus 5 plus 5 plus 5 was 25 feet. I said, builder, my house is going to be 25 feet across. And builder said, person building with me, yes. Yes, no? So the scale factor compares the actual to the representation. Scale drawing would just be what it looks like, right? Okay. So when you have a problem like now letter A here, I want to know on my drawing, here's my house. Here's my front door. And I said to my builder, I'm like, builder, how wide is my front door? And the builder said, figure it out yourself, you're a math teacher. He said 1 inch is 5 feet. So I took my ruler and I measured my front door across. Guess how far across it was? It was 1 inch across. So my front door is 1 inch across. So I know that 1 inch is 5 feet because my builder said that that's how he drew his drawings. And I know that my front door, when I measured it, was 1 inch. The only thing I didn't know was what it was in feet. I did my little bubble deal here. I know that to go from 1 to 1, I multiply by 1. And so to go from 5 to x, I multiply by 1. So how wide is my front door? 5 feet. Okay, it works in the opposite direction. So my wife wanted a 40-foot ceiling. So I said to the builder, I'm like, okay, so my wife wants a 40-foot ceiling, a 40-foot roof. So he's like, well, here's your house. I'm like, well, how high is this drawing? He goes, well, do the math. You know that 1 inch is 5 feet. You know your wife wants a 40-foot roof. Do the math and figure out what x is. And we figured out that x was 8 inches. So this was an 8-inch tall drawing, right? Yes or no?
Yes.
You can set these proportions up and solve. I'm going to skip over the map one, and then I'm going to go down to our last one, which I thought was pretty important. We compared proportions to cause and effect. The equal sign is the therefore. The equal sign is therefore. So when I look at my setup here, I'm going to go back up to my house. My builder said 1 inch. Stop. My builder said 1 inch is 5 feet. Therefore, you can see the equal sign here? 1 inch is 5 feet. Therefore, x inches is 40 feet. The only thing I didn't know was the x inches. So if 1 inch is 5 feet, therefore I can conclude that x inches would be 40 feet. Yes, no?